We have spent years staring into the vastness of the universe, thinking it was out of reach, until we started building our way toward it.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have liftoff.
Today we are here in IIT Madras to cover one of the startups that we wanted to cover for a very long time. It's called Agnikul Cosmos. It's an Indian rocket company that makes rockets to send small satellites into space. So we are doing what we do best. We are here, we're stepping inside of the company to ask the most important questions. So let's go. Hi Srinath, how's it going?
Hi Tanvi, welcome to Agnikul.
Thank you for having us here. I'm good. How are you?
I'm doing good.
What does your day look like today?
Busy day, and I should tell you that it's one of the most pleasant days in Chennai. But nothing like actually, coming and seeing this in person. So thank you for taking time.
I'm excited to see some rockets.
Yeah, definitely. That's the plan.
If you zoom out a bit, India's space story didn't always look like it does today. There is this image that keeps coming up, a rocket being transported on a bicycle, and even a New York Times cartoon during the Mars mission showing India knocking on the door of an elite space club. For a long time, that was the perception. Resourceful but limited. But over time, that story has changed. India went from launching basic satellites to reaching the moon's south pole, becoming the first country to land there at a fraction of global mission costs. And for decades, all of this was driven by one institution, ISRO. But over the last few years, something has started to shift. India opened up its space sector to private companies, allowing startups to build rockets, satellites, and even launch their own missions. At the same time, the global space economy quietly kept growing, already worth over $400 billion and expected to cross $1 trillion in the next decade. There are now over 10,000 satellites in orbit, a number that's grown nearly 10x in just the last decade. Which means space isn't just a government game anymore. It's a business. And that's where things started getting really interesting for us. A lot of the companies trying to build in this space seem to be coming from the same place, that is IIT Madras. And one name kept popping up. Because while others were building software and data layers, this company was building rockets. The deeper we looked, the crazier it got. A fully 3D printed rocket engine, their own launch vehicle, and inside a college campus, a mobile launchpad. At that point, we had way too many questions. How does a private company even start building rockets in India? What does that even take? So we reached out to the founders and came to IIT Madras to see it for ourselves. Welcome to Agnikul Cosmos.
Okay, wow.
So this is what they call a small rocket. So you can imagine what a big rocket looks like.
I cannot even imagine.
Now walking in here, you need to understand one thing. Today, India is growing at a pace where everything from internet usage, digital infrastructure, industrial capacity is scaling rapidly. Rockets, however, haven't changed as fast as satellites have. Over the last decade, satellites have become smaller, cheaper, and far more accessible, with companies now building entire constellations instead of single missions. But launch hasn't kept pace with that shift. It's still expensive, still limited in frequency, and still controlled by a small set of players. Which means that even as demand for space keeps growing, access to it remains tightly constrained. And that gap between how fast satellites are evolving and how slowly launch is catching up is where companies like these start to matter.
You used to work on Wall Street. What are you doing here?
So I always wanted to be a space engineer, but in India at that time, it was not the easiest of things to do, right? So I was doing an engineering degree in 2002. And that was a time where aerospace was not a very privatized thing in the country. So did that, then went on to, US to do a master's in financial engineering and then worked on Wall Street. But this itch for engineering never really left me. So finally quit all that and then reached out to a lot of people in India who actually know what it means to build rockets. And then Professor Satya Chakravarti, the person in IIT Madras, because of whom we are here, he actually was the person who said, okay, let's build rockets. And that's how Moin and I started here.
Why focus only on small satellites though? What was the problem that you were trying to solve?
Rockets are flying every day, right? So that is not a problem. But what the real challenge is the nature of cargo that's flying on a rocket has fully changed. So for example, in the past, satellites used to be like half the size of this room. But today it has become like you could actually lift one in your hand very comfortably and stand. But rockets that are just meant to be systems carrying these items to space, they have still not changed. So it felt like a force fitting a large rocket to carry a small parcel, and that didn't work. So we felt, why can't we build a small rocket for a small satellite? So that's where the whole story started.
Okay, and tell me more about this rocket. Where does the satellite go?
So the interesting part is you can almost think of it like 98% of a rocket's mass is about getting itself to space. You have 2% left. That's for the satellite. And that's how physics work. It's not like, that's not about Agnikul or Agnibaan. Any rocket in the world, they call that, hopefully I'm not getting too technical, but it's called payload fraction. How much fraction of your total weight is the payload? And that's usually around 2%, which means to carry 2 kgs to space, you need to build something of 100 kgs.
So if it's a heavier payload, then does the rocket also get bigger?
The rocket gets more powerful. So great question actually. So the rocket need not necessarily get bigger, it needs to get more powerful. And the way we do that is we add more engines. So we thought of the entire rocket like sort of like a Lego block model, where we are saying there is a core architecture, but beyond that we will add or remove engines depending upon where the customer wants to go. So if he or she wants to go to a particular orbit from a particular launch pad, maybe they need only 6 engines. Maybe they need 8 engines. We don't know what. But depending upon that, we will say we'll fit the number of engines for you there. So that flexibility actually does not exist in the market today.
But then coming back to the heavier payload question, I mean, of course, the mass is going to increase of that satellite, right? So it becomes heavier. That is what you need the engines for. But then it also becomes bigger in size.
Yes.
So-
So usually when you solve for mass weight, you typically end up getting more volume. So this volume part for it, like even until like 300, 400 kgs, this nose cone can easily accommodate. Typically, unless a satellite is extremely, weirdly constructed from a volume standpoint, usually that's automatically taken care of. You solve for mass, and in that process, automatically you get the volume.
And how many engines go in a rocket like this?
Typically, we start off with like somewhere around 4 engines. So, and we can extend it all the way up to even like, in the worst case, 21 engines or so. And again, that completely depends upon the exact orbit you're flying to, how much mass you're carrying, and where you're lifting off from.
To really understand how all of this comes together, you have to see it in action. Because a typical rocket has thousands of components coming together, and even a small failure can bring the entire system down. For Agnikul, the Sorted mission was about one thing: taking everything that they've built and proving it in a single flight.
So this is the Agnibaan Sorted, May 2024. Tell us more about that.
Commercial operational vehicle is called Agnibaan, and this is a rocket called Agnibaan Sorted, and that's an acronym for Suborbital Tech Demonstrator, where we wanted to demonstrate to our customers every bit of what we are building. So this is like a smaller version of the full scale thing. And here what we try to prove is our engines, our launch operations, working with ISRO, because they are amazingly professional and they know what they're doing. We are sort of figuring it out in the first launch particularly. So working with them, the aerodynamics, the autopilot, the software, all of those things. Again, the more you think of it like a regular vehicle, the more easy it will be to understand what's happening here, right? So we know how to fly a rocket with the full, scale and operational complexity of a commercial vehicle. So if you imagine, it's almost like you're throwing a dart into, into atmosphere, right? So you pick you pick your bullseye, which is a usual dartboard. It becomes 3-dimensional. So you can think of it as a sphere, not a circular plate. And you're trying to put a rocket through it. And in this time, winds are blowing. And in this time, Earth is doing its thing. And in this time, your engines are working. So your software has to take all of that into account and still maneuver itself into that point. So that is what this mission was about. And so for us, it was a clear indication to our customers that every bit of the technology was proven in this mission.
So we've spoken about rockets quite a bit here, but the only question that keeps coming in my head is, how do you make money out of this?
Yeah, great question. We are not a R&D lab, so we have to make money out of all this. So we are a transportation business. Any rocket company is basically building a transportation system. So how do you think of making money in a transportation business? You charge your cargo, right? And it is rupees per kg of what you transport, or how much ever you pay for the distance you're going or the destination you go. So that is the primary function that we have. We charge our customers for whatever is the mass they'll fly with us, and it's usually given as a metric in terms of dollars per kg. right? Now, the thing that most bigger rockets do is they sort of give this wholesale discount. And what I mean by that is more kgs means the per kg cost is lesser, right? That's the usual story. What we have done with Agnibaan is we have tried to make it a flat costing. So irrespective of the kgs that you're flying with us, the dollars per kg is and like what you would get in the wholesale discount. And the way we do that is through tech. Because it's not so any rocket technology has to be world class. And I think one thing that we have tried as much as possible in Agnikul is to tell our team, you're always building a world class product. Just because India is, inexpensive in some areas doesn't mean you can, compromise on the quality or something. So you're building a world class product. This has to be the absolute best in the world in whatever it is doing. So when you try to do that, the only way to reduce costs is with technology. So that's where 3D printing comes in. That's where the modularity of how the engines are set up. Similarly, that's where the whole question of are we doing it from the right launch pad? All of those things come from this fact of, okay, what flexibility can I give the customer, and will the tech allow for the pricing to work?
India's space story is actually very different from most countries. ISRO has been building rockets for over 50 years and has launched more than 400 satellites, including missions for over 30 countries. Chandrayaan 3 cost about $75 million to make. To put that into perspective, that's lower than films like Oppenheimer at around $100 million, Interstellar at roughly $165 million, and even Barbie at about $145 million. India produces over 1 million engineers every year, and places like IIT Madras are now pushing into deep tech. So when private companies enter space today, they're not starting from zero. They're building on an ecosystem that already knows how to design, test, and launch rockets. So we wanted to understand how all of this actually plays out in practice.
Why is India the best place to build a rocket companies?
You're in a country where rockets are not like new exotic things. India flies rockets, and we've been flying in for like decades now. So that's a big first step, because there is a community that understands what it means to build a rocket. You don't need to reinvent the wheel. Second, of course, it's inexpensive. You can get stuff done here better and so on. The third big part is the number of people who are fascinated by space. You have people, you have ecosystem, and it's not that costly to do a few things. Not everything is cheap, but some things are definitely cheap.
What role did ISRO play in helping you guys set all of this up?
Yeah, I think we could not have done whatever we've done without ISRO, right? So in the very early days, they actually helped us by allowing us to test our 3D printed engines in their facility. So it gave us validation that, the engine performs the same way even within an established facility. They almost ended up owning the mission as if it's their own mission in terms of helping. And that reduced time. Otherwise, you would have had to figure out all of those things as well. So just enabling a bunch of people to help us to do the launch, that was, I think, great. I think the third part is, this is not directly ISRO, but the retired ISRO community. The people who have built the first rockets of India, the first satellites of India, those are an amazing set of people, because believe it or not, ISRO was a startup at that time, before startup became a popular phrase, before it was a jargon. So those people have operated within the government, but in a startup setting. So they'll be able to connect with you in terms of what it means to build with less access, less technology, less money, and so on.
So IIT Madras gave you the land to build all of this, right? Shed some more light on that.
We are standing in IIT Madras literally. And when IIT Madras gave us this place, you can see the barren land. This is how it was. So allowing us and trusting us to build this, all of what you see here, that is amazing, right? We are among the very first companies to start. So we needed the IIT Madras credibility, because otherwise you go out and say you're building rockets, people are first going to think you're just talking something. So then the other aspect is this whole incubation aspect, right? Where you now suddenly meet a lot of like-minded people who are all building something which most people are not believing will work. And so suddenly it normalizes the unconventional aspect of what you're doing.
So your Series A in 2021 was the largest for a private space player at the time. What gave investors the confidence to invest in an idea like this?
So I think at that point, we were in the peak in the middle of COVID actually, right? And space startups were also just starting to come up at that time. For us, it has always been tech milestones driven. So I think right before that, we had fired a single piece 3D printed rocket engine. So that gave people confidence. We were also established to build all aspects of the technology, because rockets are not only about engines. It's about electronics, software, structural items, and so on. So we were able to tell our investors, and investors were able to also see that progress has happened everywhere. So I think that is what gave them the confidence.
So InSpace came in as a regulator for these private space entities, right? Yes. So what was it like pre-2020 and now?
One of the questions that was very difficult to answer before 2020 was before InSpace announcement was basically, is it legal to privately build and launch a rocket in India? Because the answer was not clear, right? And some people said there's no answer, so say yes. Some people said no answer means no. So all of that got sorted only with the announcement of InSpace, right? And I remember vividly, like in May of 2020, we were all in the middle of lockdowns. There was an announcement about Atmanirbhar that came up. And if you remember, the finance minister was actually presenting, and on the side there was like half the TV screen was about each initiative. And out of the blue, suddenly there was space. And none of us expected that, right? And it was like an announcement saying that there's going to be a new entity that's going to be set up. It's about enabling private space tech startups and all that. And so that very night, we sat and wrote an email to Chairman ISRO saying, we heard about InSpace or a new body coming up. Can you give us permission to launch? So if you remember, I told you, right, we are a spacefaring nation, but being a spacefaring nation doesn't mean that you can go privately and do things. But yeah, I think without InSpace, again, this whole thing would have been just a R&D effort in some lab in IIT.
Now I'm sure we've all seen those space movies, the big countdowns, the control rooms, everything building up to that one moment. But when you actually look at a mission control room, there's no drama to it. Just data coming in, people tracking their systems, and slowly everything narrows down to just one decision. Is this go for launch or not?
Hi, Uma.
Hi.
Hi. Nice to meet you. Nice to. So this is where it all happens. Can you tell me a little bit more about what you do here exactly?
So I'm the mission director for the Agnibaan Sorted mission. So here I take care of, once the vehicle is ready for the launch, I take care of integrating it with the Launchpad and getting all the subsystem level testing done and completely getting it done for the mission.
So we've also heard that you've said no to a couple of launches. So what exactly does that take to say no on launch day when there are a lot of people watching? There's ISRO watching, there's the founders watching, your team members watching. What exactly does it take?
So it is usually what the vehicle wants. So there are multiple checks that we do in the back end. There are various health parameters that are being monitored. So it is ultimately what is required for the mission. If certain things are not okay and it will not be okay for the mission, then we have to say no if it is not good for the mission, not good for the vehicle.
But even if you solve for the rocket, there's another problem here. Where exactly are you going to launch it from? Because in India, most launches still happen out of one main site, which is Sriharikota. So instead of relying on it, they built India's first privately developed mobile launch pad, bringing the entire system under their control.
So you basically put Agnibaan together.
Yeah.
Okay, so that involves 10,000 parts coming together. What exactly gives you the confidence that it's going to fly?
So any component which goes into the flight has to be rigorously tested in the ground. That is the confidence we get. When there are so many parts, we build so many test rigs to make sure that we test each and every part which goes into the vehicle. That is the confidence we get testing.
Okay, and what is one mistake that other deep tech startups make that you are very sure that Agnikul won't end up making?
We actually make bold innovation whichever the vehicle demands for. That is something which we have never shied away. We have also seen people shying away from making history, right? So that is also something which we have been trying, starting from the 3D printing, the mobile launchpad and everything. We also, whenever I say innovation, it is not about spending too much money. We try to make a frugal innovation. So these are the things I think we constantly try to avoid in Agnikul.
Tell us a bit more about the mobile launchpad, that is Dhanush, right?
When we started designing the launch vehicle as well as the launchpad. So the launch vehicle was also designed in such a way that everything is mobile. Even no pyro system, we made a reason because we wanted to make it mobile. Then why to keep the launchpad fixed, right? So that is where this whole concept of Dhanush came into picture. We made sure that every component which we are making, even including the launchpad, is movable. It can go to even other launch ports, whichever is possible, and then we can launch from that location. So that is the idea.
Another thing that stood out to me when I got there was how they're thinking about the engine. They're using semi-cryogenic propulsion, which basically means liquid oxygen combined with a refined fuel. So you get a lot more control over how the fuel burns and in turn better efficiency. But what is more interesting is how they're actually building it. Instead of assembling the engine from multiple parts, they're 3D printing it as a single integrated unit.
Can you tell us a bit more about what you do here at Agnikul?
So I take care of additive manufacturing and design process that goes into the additive manufacturing part. And this is the 3D printer. So this is the machine that printed the actual engine which flew in our suborbital mission. And it is printing many more parts that will fly very soon.
So how did the idea of 3D printing the engine come about? I mean, it's a single piece. Why not just assemble it bit by bit?
So one of the most challenging part of manufacturing a rocket engine is like the seals. Basically, whenever we attach 2 points, there is always a chance the joining area might fail. So we have seen plenty of rocket launches and even spacecraft missions that fail because of a seal. So that is where we got the idea of making it single piece.
How difficult is it to build a company like this out of India?
So one of the challenging part is basically the infrastructures that is required to manufacture the engines or the parts of the rocket. So we had to find unique places across India where they can process each steps of the manufacturing. And we found that to be most challenging part. And that is one of the reason why we set up this facility itself, where all the machines that is required to make a full engine are at one place, so that we can avoid the travel as much as possible and the quality part of the engine, so that can be maintained.
Also, I see an engine here.
Yeah.
This is what will actually go in the rocket.
Yes, so this is our first stage engine. This is what will be flying in our first orbital mission. And it is a very special engine because again, it's also a single piece design one, but it's actually very large. It's a 1 meter single piece engine. Nobody has done it in the world. So in that way, it's very unique.
At this point, it's not just one product being built. It's multiple systems, teams, and decisions all happening at the same time. And the real challenge is keeping all of it aligned, making sure nothing slips. That is where Giri comes in.
What is one thing that you really underestimated about this particular role?
Two things. One is about the coordination part, right? So when you look at a company, right, usually in any other company, there will be one guy who's doing HR operations. There will be one guy who will be doing, finance, and then there will be one engineering team. Engineering is a word, then that company will revolve around that. But here, when you talk about engineering, there will be some 10 streams of engineering that you have to look into. There will be software guys, there will be mechanical guys, structural guys. In structural itself, there will be dynamics guys, there will be people who talks about composites. So coordinating with all of them and building one product together, that's where the challenge lies. Now you have to coordinate everything and push everything in a direction that you want and build one product that works in a direction that you want.
We also heard that you went back to writing code once, leaving chief of staff, and then because the situation required that. So how do you actually context switch?
Whatever the problem is, you have to solve that problem. So suddenly one night it's like, let's write software because that's where the problem is. So I have to chip in. And obviously it's Srinath and mine who always pushes me, my limits, and make me work in things which I am not comfortable with.
Hardware in India is still early. Access to specialized manufacturing, testing, and launch are still limited, which is why most companies go deep in only one layer. But here they were doing the exact opposite, building across multiple layers in a space where speed and frequency are already picking up globally.
So from the outside, it looks like you're doing quite a bit, right? The 3D printing engine, the semi-cryogenic bit of it, the mobile launch pad. Why not just focus on one single thing?
So rocket is an integrated product. So if you're building something that requires integration, you need multiple parts for it. To make that multiple parts, you have something called as a quality constraint. Depending upon others, is for a critical system is definitely not appreciated. So you have to do as much as you can. So for those reasons, as much as that we can do, manufacturing in-house or building anything, it's all conceived here. And more importantly, we wanted to focus and build a 21st century rocket, not an old rocket anymore. So to do that, you require innovation. And for that perspective, we were thinking that everything has to be done in-house. And I think that's what you've been doing things in-house. Yeah.
So Agnikul plans to do 100 launches by 2030.
Yes.
Okay, so what will need to come together to actually make that happen?
We divide this into two parts. One is building a rocket, and then one is launching the rocket. So if you're building 100 times a rocket, it also has to be launched 100 times. So that's the perspective that we actually take it. And now for building a rocket, you have a couple of things. Number one would be about the quality of the product that you're building. Number two is the execution of the launch. So both of these things have to come together for any launch to be successful. I think we've seen this in the past as well, right? So SpaceX started with doing one launch a year. Oh, I think last year they did around 160 launches. So what happens is like once you excel in building the product at quality, your execution for launch operations also gets a little better. So the number that we are saying 100 launches is not a very far-fetched thing because today 160 launches a year is happening. So we should be able to target that number. It is, and obviously that's what we actually say, but we would love to do a lot more launches by 2030.
The future isn't defined by who has the best ideas. It's defined by who actually gets to build them. For a long time, that list was very small, limited by cost, access, and infrastructure. But that is starting to change. And when that changes, everything changes. With companies like Agnikul, India isn't just participating anymore. It's starting to shape what comes next. For them, the story is just getting started. And this is business.